So Chapter 10, Lesson 5 is surface area of prisms. And here we wanted to write all this vocabulary in our spiral so that we know this for later. A pyramid is a three-dimensional figure with at least 3 triangular sides that meet at a common vertex and only one base that is a polygon. Okay? So remember, a vertex is the point where all of these triangles meet, right? The base is that bottom face down there, okay? And it is a polygon. It could be a square, could be a rectangle, could be a triangle, okay? So that is what a pyramid is, okay? Now the lateral faces of the triangular sides, the lateral faces are the triangular sides of the pyramid. So here is a lateral face. This front one is a lateral face. We've got one in the back here. And then we've got another one back there. Those are the lateral faces. And the slant height is the height of each of those lateral faces. You see this dotted line, remember, it drops down to a right angle. That gives me the height of that lateral triangle face. All right, so here we also want to label the pieces. So here, what do we call that right there? That's the vertex. Very good. And then we've got, this is now, it's pointing to this back piece. That's called a lateral face. Very good. And then this dotted line is the slant height. Very good. Please make sure you know how to identify those items on your diagrams, okay? So here we want to draw the faces of the pyramid, okay? So here we have this pyramid, and each one of those faces is a triangle, right? So each of the lateral faces are triangles. And they all pretty much look the same, right? And then the bottom, you see here, is going to be a square. Very good. And that's what it looks like. So here is surface area of a pyramid. The surface area of a pyramid is the sum of the area of the base and all of the areas of the lateral faces. So here with this picture, the base is a square or a parallelogram or a quadrilateral, okay? And then each one of the lateral faces is a triangle, okay? This again is the net view. You remember how it explodes and it lays flat. This is the net view, okay? And we've already written this diagram, so let's take a look at our example. Is everybody ready? All right. So here, the surface area of a pyramid. We want to use the net to find the area of each face and then add them to find the total surface area. So here, does everybody see this is a square, the 7 by 7? Yeah. Now notice that the base, so the base for all of the triangles is the same, right? What about the height of all of the triangles? They're all the same, 9, 9, 9, 9. So so that means that they're all going to have the same area, right? So couldn't I just find the area of one of those triangles and multiply times 4? Yeah. Yes, very good. So we have the base times the height, and then we'll multiply times 4. And when we do that, then we end up, well, one of them is 31.5, okay? The base is 7 times 7, okay, which is 49, and when we add them all together, we get 175 square centimeters. Now, what did they not do here that I expect to see in your notes? They didn't write the formulas. I would like for you to make sure that when you are showing your work, you are writing your formulas. Is everybody clear? Yes. Okay. All right. So here we want to find the area surface area of each of these pyramids. Now, once again, we can see that our base is what shape? Well, it's a 16 by 16, so it's a square. Very good. So we can find the area of that square base, which is length times width. So that's going to be 16 times 16. All right, so this is equal to 256 feet squared. If you want to wait till the very end to put your units, I'm okay with that. Okay, just don't forget to put them at the end. Okay? Now we find the area of the 4 triangular faces. Now, those are the lateral faces, and we can see their triangles. And it's base 1/2 times the base times the height. And we have 4 of them, so we're going to multiply times 4. Okay? So now, before I even start with my substitution, can you see that I can simplify the 2 and the 4? I can simplify that immediately, right? So now I can substitute in what I know. So I've got 2 times the base, which is 16, times the height of that lateral face, which is 12. Very good. Times 12. This is equal to 394, and again, that's feet squared. Good. So now, to add up all of our faces to get our total surface area. So we're going to add 256 plus the 394, and that will give us our total surface area. Okay. So that gives us 650 feet squared. And that's it. All right, so here we have surface area of pyramids with triangular bases. And that's this one right here. Does everybody see that? See, it says all triangles, and there's a triangular base. Got it? All right. So it says a triangular pyramid has 1 triangular base and 3 triangular faces. If the base is an equilateral triangle, then that means all 3 faces are congruent. Just like when we have a base that is a square, all the triangles are congruent. Does that make sense? Okay? So, that's a little shortcut that you can take. If the sides of the base of the triangle have different lengths, then the areas of the lateral faces will also vary, which means that if it's not an equilateral triangle, we have to find the area of each one of the triangular faces separately and then add them together. Got it? Okay? Which brings me back to the note of the rectangular ones also. Some pyramids have square or rectangular bases. So here you can use a net to find the surface area of this kind of pyramid. Note that a rectangle has opposite sides congruent, right? So if I find one, I can multiply times 2 to get the other, right? And then I'd have to find the area of the other 2 sides, find 1, and then multiply 2 to get both of them, right? Okay? So let's go back to the triangular pyramids. So here it says the surface area, find the surface area of the pyramid. So this is our pyramid. Here is our, the shapes of all of the faces. And you can see they're all triangles. So 1/2 base times height. Okay? Now, this is 4, this is 4, this is 4. So this base is what kind of triangle? Equilateral triangle. So for this, you can see base times height, base times height, base times height. They're all the same, right? So all I'd have to do for the lateral faces is multiply by 3. Very good. Find your area of the triangle, then multiply times 3. and see 10 plus 10 plus 10, that's repeated addition, which is multiplication. So all you have to do is multiply the 10 times 3 and then add the area of the base. So that gives us 37 square feet. So here we want to find the surface area of each of these triangular prisms. Now, these are, let's see, that's 2, and that's 2. That's an equilateral triangle. So all you're going to do is you're going to find the area of one of the lateral faces and multiply times 3, right? And then you're going to find the area of the triangular base, and then you'll just add those together, right? All right. So first thing we're going to do is we're going to find the area of the triangular base. So once again, we have 1/2 base times height. And see here, I traced it in black. Okay. So we want the base of this triangle, which is 2. And the height of this triangle right there is 1.7. Very good. So we've got 1/2 times the base, which is 2, times the height, which is 1.7. Oh, this is going to be so easy. All right, so I'm going to, because I have so many dots up here, I'm going to put 1.7 in parentheses so you don't confuse it with another multiplication sign, okay? So what happens to the 1/2 and the 2? Simplifies out. Look at that. So now it's 1 times 1.7, which is 1.7. Very good. And I'm going to write my units at the end. It's going to be centimeters squared, right? So now we want to find the area of the 3 triangular faces. So here is, let's see, which one do I want to get? That's the back. Does everybody see that? That's the back triangle. Let's see. This one is the side triangle, right? And let's see, I think it's this one. And that one is the front triangle. So what's the base of this triangle? 2. And the height of this triangle is 3.5. Very good. So now we can substitute in. So let's see, we've got 3, because we're going to multiply times the 3 faces, times 1/2, times the base, which was 2, times the height, which is 3.5. 3.5. And I'm going to put this in parentheses again. And of course, we're going to need 2 parentheses here like this, right? Okay. So now I can simplify. So again, what happens to those 2's? They cancel out. Good. So now we just have 3 times 3.5. So here, this is equal to, whoops, because I picked the wrong color. So this is going to be 10.5. So now we're going to add up all of the sum of all the faces. So this is the base. So that's 1.7 plus this 10.5. That is the area of all 3 triangular lateral faces, right? So that's going to be plus 10.5. So here, the area of this triangular pyramid is 12.2, and it's, what's the units? Centimeters squared. Very good. Centimeters squared. All right, so for example B, we are going to change this example to be a rectangular pyramid. Okay, we're going to change it to a rectangular pyramid, and we're going to change the dimensions to be 3 by 4. So the first thing we want to do is we want to find the area of this now rectangular base. And of course, a rectangle, the area of a rectangle is length times width, right? So the length there is 3, and the width is 4. So that's what we're going to substitute in. So we've got 3 times 4, which is equal to 12 inches squared. Okay? Now we want to find the area of the two triangular faces that have a base of 3, and then we're going to do the same thing to find the other two triangular faces that have a base of 4. Okay? So one more change that we made in this example is that this slant height is going to be 5 inches. So we want to find the area of the two triangular faces that have the base of 4 and the height, slant height of 5. So we're just going to simplify, substitute. Oh, but actually, before I simplify, can I simplify these 2's? Okay, so we can simplify those 2's to 1, and the reason we're multiplying times 2, of course, is because there are two identical triangles, right? So we've got 1/2 base times height, and then since we have 2 of them, we're multiplying times 2. Is everybody with me? All right, so now we can substitute the rest of what we know. So the base there is 4, and the height is 5. So the area of those two triangles total up to 20 inches squared. Very good. So now we want to find the area of the two triangles that have the height of 4.5 and a base of 3. So we're going to substitute those in. And once again, before I even start this problem, I can simplify those 2's, right? So the base, oh, and we're going to call this pink, right? Pink 2. The two triangles with the pink height. So the base of that triangle is 3. And the height of that triangle, or both of those triangles, is 4.5. Very good. The area of those two triangles is 13.5 inches squared. Clear? So now, to get the sum of all of the faces, which is going to give us the surface area of that pyramid, that rectangular pyramid, we're going to add up all of the faces, the sum of the faces. So we've got the 12-inch base, 12-inch squared base. We've got the two 20-inch squared red triangles, and then in the two pink triangles, those added up to 13.5 inches squared. So when we add that all up, so that's going to be 45.5, 45.5, and what are my units?
Inches squared.
Very good. Inches squared. All right, so we're going to do example D, right? And here we're going to change this because I wanted to show you how to do this if it's not an equilateral triangle, okay? So, because all of the examples in the textbook are equilateral triangles, okay? So here I just changed a couple of the measures. So you can see now we have 6 meters for this side of the base, 5 meters for this side of the base, and 7 meters for that side of the base. Is everybody with me? And then I'm going to go ahead and use, for the slant height, I'm going to use 8.3 for all of them. Okay? So, the first thing we want to do when we are, the first thing we want to do is to find the area of the triangular base. So first we're going to write our formula, 1/2 base times height. So when we substitute in, we've got 1/2 times the base, which is 6, times the height, which is the height right here, is very good, 5.2. And I'm going to put this in, the 5.2 in parentheses, okay? Because I don't want to confuse so many of the dots or decimals with multiplication. Can I simplify before I multiply? Yeah. So I can simplify the 2 and the 6. So 2 divided by 2 is 1. 6 divided by 2 is 3. And now all I have to do is multiply 5.2 times 3. So here we've got 15.6. What are my units going to be? Meters squared, right? And I'll just wait till the end to put that. So now we want to find the area of the first triangular face. So now we want to find the area of all 3 faces. So I'm going to have to move up and down here. So here, the area of the first triangular face, again, 1/2 base times height. So which one do we want to look at? Let's look at this one. Okay, so that one, what's the base? 5. What's the height? 8.3. And then we're going to multiply that times 1/2, right? All right, so let's substitute that in. So we have 1/2 times the base, which is 5, times the height, which is 8.3. And looks like we cannot simplify anything there, right? So that face is 20.75. Okay? So now we want to find the area of the second face. All right. So now let's do this triangular face. So what's the base? 6. What's the height? It's going to be the same as this one over here, so that's going to be 8.3, right? So now we can substitute what we know. So we have 1/2 times the base, which is 6, times the height, which is 8.3. And now, can I simplify before I multiply? Yes, thank goodness, right? So 2 divided by 2 is 1, and 6 divided by 2 is 3. So we're going to multiply 8.3 times 3, which gives us 24.9. Look, we didn't have to write the work on that. So 24.9. Very good. What are my units going to be?
Meters squared.
Meters squared. Very good. So now we want to find the area of the third face, right? So let me move this out of the way, and the only one we have left is that one back there, right? It's that one. So what is the base here? 7. And what is the slant height going to be? Same as this one, right? So that's going to be 8.3. Okay? So when we substitute in, we have 1/2 times the base, which was 7, times the height, which is 8.3. So we're going to have to do this on our scratch paper. So this is going to give us 29.05. So now to find the sum of the faces, or the total surface area, we just add them all together. So we're going to add, let's see, the area of the base was 15.6. 15.6 plus what? 20.75 plus, I'm going to come down here, plus 24.9 plus 29.05. Very good. So when we add all those together, what do you get? So we get 90.3. And what are my units?
Meters squared.
Meters squared. And finally, for example 3, it says a pyramid puzzle has all sides that are equilateral triangles. Each triangle has side lengths of 8 centimeters. The slant height is 6.9 centimeters, and we want to find the surface area of the puzzle. So the first thing we can do is we can create a net and then use it to find the surface area of the pyramid. So we have an equilateral triangle as a base, and it said it was 8 centimeters 8 centimeters for each of the lengths. Okay? Then the slant height for all of them is 6.9 centimeters. So we can find the area of the base, which would be the 8, the base times the height, 6.9, divided by 2, or times 1/2. Actually, if we look at this, they all have a base of 6. They all have, 8. They all have a slant height of 6.9. So that means they're all the same. We can just find the area of one triangle and multiply times 1, 2, 3, and 4. So here, when we do that, 1/2 times the base times the height, that gives us 27.6 square centimeters. So the surface area of this puzzle is at 27.6 times the 4 triangles, which gives us 110.4 centimeters squared. And that's it.